Okay guys, this is page 16 in your packet. I'm going to go over all those problems, and this is the last thing that's going to be on your quiz. It is solving exponential and logarithmic functions. Remember, page 16. So I'm going to go a little bit quicker than I do in class, because if you need to get caught up, remember, you can always pause. All right, so the big takeaway from this is we're going to write everything in exponents. You really don't solve a log. You're just going to turn most of it into exponential form. And when you are done with these notes, go ahead and go back to Canvas and drop this in the submission where you're supposed to turn in your completed notes for Friday, May 6th. All right, let's jump in, guys. Here we are with number 1. It is a log. So what we're going to do is we're going to convert it to exponential form. So remember, it is equal to an exponent. So this is going to be 16 to the x equals 1 over 4. And also remember, it is all about the same base. So 16 and 1/4 are not the same. 16, I can make a 4. 16 is 4 squared. So there's your 16 raised to the x. Oh, and that's 1/4, but they're still not the same yet. So we're going to leave this alone. We're going to change that. So this is going to be 4 to the 2x. I'm just going to multiply those together. And remember, that is 4 to the first power at the bottom. It's going to be 4 to the negative first power at the top. Now we're ready to go. Once the bases are the same, you just solve the exponents. The exponents are 2x equals -1. Divide both sides by 2, and you get x to equal a -1/2. That's it. All right, for problem number 2, we have another log here. We're going to put this in exponential form. So this is going to be 9 to the 5/2, and it is going to equal x. Now, remember, if I did 9 to the 5th power and try to take the square root of that, that is not going to be an even power. I really want to get rid of this denominator. Now, don't write this down. If I did like last time we solved problems with a denominator, we multiplied both sides by a denominator, and here's what we would get. We would get 9 to the 5th equals x squared. So that's even worse than just a single x. So don't do that. If you can, break down the 9, and you can break down the 9. So let me rewrite the way the problem looked originally before I did the wrong step. So focus on your base. In this unit, always focus on your base. Can you break 3 down? You can. 9 is 3 squared. So if I take 3 squared, remember that's 9, and it is being risen to the 5/2. Y'all, those 2's are going to cancel out. So remember, if you see something weird and you don't know what to do from there, focus on the base. So these are going to cancel out, and now we're going to have 3 to the 5th equals x, and 3 to the 5th is 243. It's still on the board. It's 243. So 243 equals x. Box it in, and let's keep rolling. All right, number 3, we have 2 logs equaling each other, and their bases are identical. We can just drop the log and the base all together and just solve what's in parentheses. That's only going to happen when these are absolutely the same. So this is going to be 3x minus 5 equals 2x plus 4. So when you do the correct math on this is a junior high problem, by the way, this is going to be x equals 9. And that's going to be it for problem number 3. For problem number 4, we are going to set this up in exponential form. But first of all, I just want to reward you and kind of give you a little extra boost if you do have volume on and you're not just watching me on mute. If you have volume on, I am going to tell you a joke, and I'm going to ask you about this joke on Monday. And if you tell me what the joke was, you're going to get some extra credit for this assignment. The joke is, knock, knock, who's there? Orange. Orange who? Knock, knock. Who's there? Orange. Orange who? Knock, knock. Who's there? Aren't you glad I didn't say orange? Totally stupid joke, but it's going to get you extra credit. All right, back from that silly joke, and I think I told it wrong, but I don't care. All right, so this is going to be 4 to the 3rd power. Remember, it equals an exponent. So 4 to the 3rd power equals 4x minus 6. 4 to the 3rd power is 64. So guys, this also turns into a junior high level problem. Just solve for x. So when we add 16 to both sides, we get 80. Go ahead and divide by 4. You're going to get x to equal 20. And that's going to be it. And that problem's a lot better than that knock-knock joke. That was silly. All right, number 5. I've got more, by the way. On number 5, this is 2 logs that equal each other, so we're just going to set the arguments equal to each other. So it's going to look like this. So this is a high school problem, so you got to move this stuff over. Remember, you don't move the x squared. The 0 is going to be on this side. So it's going to be x squared minus x minus 12. That's factorable. Everything should be factorable in this unit. So that's going to be x minus 4, x plus 3. So x is going to equal a positive 4 and a negative 3. And when I have these answers, I'm just going to make sure that I get a positive number here, and I do. So I can use my good group. So you can just put it in answer form like that. By the way, what color pen am I using? That's another bonus. All right, let's keep going. This is going to be the most embarrassing of the little hints if you have your volume on. For this right here, this is log base 10. Remember, it's not written. So we have 10 to the third equals x plus 7. And I'm going to stop and give you the last hint. No, this is another extra hint. If you have your audio on, I'm going to ask you about what song I'm singing right now. And it's Twinkle, Twinkle, Little Star. So, twinkle, twinkle, little star, how I wonder what you are. That's very embarrassing, even though I'm in here by myself. So, what song did I sing? You know what song I sang. Guys, I went ahead and expanded 10 to the third. It's just 1,000. So, we're just going to solve for x. Just subtract 7 from both sides. So, this is going to be x equals 993. All right, next one. So for the next one, this is already in exponential form, but guys, you've got to remember it is all about the same base. So I can't make a 4 into a 16, but I can totally make 16 into a 4. So this is going to be 4x to the 5th. And remember, this is 4 squared. We've got our same bases. Let's drop the bases and just solve for the exponent. So x minus 5 equals 2. Move that 5 over, you get x to equal 7. Pretty easy as long as you write the same base. Last one is 27 to the x equals 81. And it's not a log form, so we're already in exponential form. Same base. Both of these are 3's to some power. When we write it, we're going to be rolling. By the way, your last clue is that is a quarter note. So if I ask you what music note was on the screen or on the video, quarter note. So this is going to be 3 to the third. Y'all, that's your 27. Remember, 81 is 3 to the 5th. So we're going to write this as the same power. So once we have the same power, hold on. That's not 3 to the 5th. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, y'all. This is 3 to the 4th. I'm sorry. So I just have another one. I can ask you what mistake I made. All right, so this is now having the same base. This is just going to be 3x equals 4. Divide both sides by 3, y'all. X is just 4/3. And that's really it. That's all that the logarithmics are. Here's your assignment. This assignment is page 17, 1, 2, 3, 6, 8, 10. That's it. This is not turned in on Canvas. Remember, the only thing that you turn in on Canvas are your notes, so go submit that right now. But just show me this in class on Monday. And if you had your audio on, thank you so much for having your audio on.